Okay, good morning, everyone. Please take your calculator out so we can get started. Just a reminder that I will be in the classroom tomorrow morning, and the retake is Thursday. You are to complete your homework. Okay, it's at the end of this packet. So at this point on your looking ahead, you should have questions 1, 2, and 3 answered. And we should be, 1, 2, and 3 answered, and then repeat number 3, what does a z-score measure? So you should be able to write down that a z-score measures the number of standard deviations above or below the mean. That a value lies. Okay, how do you compute the z-score? You should be very comfortable doing this. You take your data value, you subtract the mean, and divide by the standard deviation. Okay, what are the properties of the normal distribution? You should say, okay, it's symmetric, the center is the mean, it's symmetric, and furthermore, it's unimodal, and it's bell-shaped. So it's not just symmetric, it's also unimodal. Okay. So today what we're going to look at is how can we determine probabilities. We won't be using the empirical rule. Okay, so in your notes, let's start there. From last class, we have a Virginia Cooperative Extension reports the mean weight of Angus steerlings. We have the mean is over 1,000 pounds and the standard deviation. What is the z-score for someone that weighs 950? So I'm going to do 950 minus 1152 divided by 84, and I get negative 2.40. So 2.4 standard deviations below average. What would it mean if you had a z-score of 0.75? That would mean that your 0.75 standard deviations above, because it's positive, average. And we know the average weight to be 1,152 pounds. Calculate the steer's weight if the z-score is 0.75. Okay, so 0.75 is the z-score equals the value minus the mean divided by the standard deviation of 84. So we can cross multiply here. We get x minus 1152 equals 0.75 times 84, which is 63. Add the 1152 to both sides. So a little bit of algebra here, more than we're used to. And we get the weight to be 1,215 pounds. Okay, so we use the z-score formula to solve. Which would be more unusual? More unusual, you want to calculate each z-score and see which is further above or below the mean. So you can pause the video here, take a moment to calculate each z-score. For 1,000, you should get the z-score to equal negative 1.81. For 1,250, you should get the z-score to equal 1.17. So which is further from the mean? This one. It's more unusual on the low end. So that's a recap from last class. What we're going to look at today is the normal distribution. So a reminder from yesterday, it's a distribution for a continuous variable. We used the empirical rule yesterday with those percentages to estimate probabilities. What we're going to do today is calculate exact probabilities. So what exactly is a probability or a proportion or a percent? It's the likelihood of something happening. So it's either from 0% to 100%, or it's a proportion from 0 to 1. Okay. What do you need to know in order to draw the normal curve? Well, you need to know just the mean and the standard deviation. So the mean is always the center. We'll draw a generic curve. So we have the mean in the center, and this is usually our notation, approximately normal. And if we're talking about the weights of those Angus steers, the mean was 1152, and the standard deviation was 84. So I do need you to have your calculators out, please. So make sure you have them out and ready. So as we flip over our notes, this is clearer on your page than it is on mine. So we are going to start with drawing and labeling the curve, shading the curve in the proper direction, calculate your z-score, and then use your calculator. And I tell you where to use your calculator. So in your calculator, you are going to hit second, then vars. So turn your calculator on, hit second, then vars, and then we are going to use the normal CDF function. It's number 2. Make sure it says CDF. Okay. When you get there, your calculator will ask you for some values. If your calculator doesn't look like this, then it might be going across, and your calculator would look more like this picture. Okay, so let's try this one. So same example as before, same mean, same standard deviation. We're going to start with drawing a picture. We want to know what percent of steers weigh 1,000 pounds or more. So if I draw my curve, I know the center is 1,152. I know 1,000 is below that, and I want to know or more, so I'm going to shade above. My second step is going to be to find that z-score. So I'm going to do 1,000 minus 1,152 divided by the standard deviation. And we always leave z-scores as 2 decimals, so I get negative 1.81. This is the work you must show to get credit. I know that you can go to your calculator and just get the answer. If you took IB last year, you're probably already remembering this, but you must show this work in order to get credit. So now at this point, you're going to go to your calculator and we're going to do normal CDF. Where did we start shading? Well, we started at 1,000, so we're going to do 1,000 up to a really, really, really high number. So you can do like 1,000,000 or even higher. Then we do comma the mean, 1,152, comma the standard deviation. So I'll show you what this looks like in the calculator. So we're going to do 1,000, oops. So second vars, normal CDF, the second one, we're going to do 1,000. Then a really large number, just type in a bunch of zeros, the mean, and the standard deviation. If you have a different calculator, it comes up all as commas. You'll just type this in terms of commas in your calculator, normal CDF, the 1,000, comma, comma, comma. And then this answer that we get here is a proportion or a percentage. So we get as our answer, it was asking as a percent. So as a percent, this is 96.48%. So almost all of them weigh more than 1,000 pounds. So for the second one, what percent weigh 1,250 pounds or less? I'm going to start by drawing my curve, centered at 1,152. 1,250, you notice this isn't perfect, or less, so I'm shading below. I need to find that z-score. So 1,250 minus the mean, divide by the standard deviation, and I get my z-score to be 1.17. When I go to my calculator for normal CDF, I'm going to do norm CDF. I'm going to type in where do I start shading. So it always has to be the lowest number. So I'm down here at like negative infinity. So I'm going to type in negative 1,000,000. I'm stopping at 1,250, comma the mean, comma the standard deviation. When you type that in your calculator, you get 87.83%. Okay. One more together. What percent of steers weigh between these two values? So drawing my curve again, 1,152, 1,150 is below, 1,200 is above, shading in between. Now I need to find two z-scores. So my first z-score is negative 0.02. My second z-score, if you calculate it, is 0.57. Then I'm going to do normal CDF, and I'm going to go from 1,150 to 1,200, comma the mean, comma the standard deviation, and you get 22.56%. Okay, so it's your turn to now try this and complete the rest for practice. If you have questions, you can go back and rewind the video. I will see you tomorrow. Good luck.